Project 1.3, the counting circuit.
The goal of this project is to create a fully functioning digit counter. To fully build and understand this project, you must first learn the 10 key components labeled on screen. On display right now is the final PCB and case, ultimately the final product. First step to understanding the counting circuit is the button input. The button input is on when the button is not pressed and off when the button is pressed. This ultimately sets up the oscillation process for the next stage and ultimately counting circuit. The next key factor to understanding the counting circuit is the NAND gate oscillator. The NAND gate oscillator provides the clock signal for the ultimate counting circuit. This clock signal is provided by the charging and discharging of the capacitors, which can vary depending on resistance. This charging and discharging creates a square wave, which ultimately sets up the base for the counting circuit. An alternate to the NAND gate oscillator is the 555 timer. The 555 timer also uses capacitors to ensure the speed and duration of the oscillation. However, I have added a potentiometer to adjust the speed of oscillation, using the resistance within the potentiometer to do so. The Decades counter key components include the 4017 IC, an LED bar graph, as well as an LED. The 4017 uses the clock signal provided by the previous steps and puts it in sequence ranging 1 through 9 and the divided by 10. However, in the final product, only the divided by 10 is used to reduce the clock signal. The binary counting includes all the previous steps, with the 4017 divided by 10 going into the clock signal of the 4510. The 4510 then provides each LED with a different value, 1 on the furthest right and 8 on the furthest left, with a different value. As well, with the switch, it can count up or down based on whether the switch is connected to the positive or negative rail. The next stage of the project incorporates two components, the 4511 binary decoder chip and a 7-segment display. The 4511 binary decoder chip takes the binary numbers provided by the previous stage and converts it into 7 outputs, labeled A through G. These outputs are connected to the 7-segment display in the correct order to ensure that the numbers are displayed accurately, ensuring that the count continues from 0 all the way to 9. To make sure that the final product is easy to use and portable, it is displayed with a PCB and a case. The battery is placed inside the case and the PCB is small and compact to ensure that the final product is portable, easy to use, and something that can be transported without much fuss. To increase the count, sections D to G have to be repeated, with the 4017 of the single digit count being connected to the clock signal of the second 4017, providing the tens digit a 10 times slower oscillation than previously. I hope that by watching this video you fully understand the counting circuit and can develop your own prototype and PCB to ensure that you have your own counting circuit.